we're getting into real-time video, we're getting into changes, we're getting into multimodal. So training is still evolving. However, now inferencing is becoming more and more important because those models are efficient. And what's super important is to build redundancies across those, right? So when they hit, that either they do not impact the full production, and then second, that you basically get back to full production as fast as possible. Well, at this point, you need the AI system to perform 100% of the time.
From Orion X in association with Inside HPC, this is the @HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hi, everyone. Welcome to the @HPC podcast. I'm Doug Black at Inside HPC, and with me is our co-host, Shaheen Khan of OrionX.net. Today with us is our special guest, Paul Bloch. He is president of DDN, the High Performance Storage and Intelligent Data Platform Company. And we're here to discuss issues around storage, data management, and data delivery in the AI at scale era. So, Paul, welcome.
Thank you very much. Thank you, Doug. Thank you, Shane. Nice to meet you guys.
Really looking forward to this. Thanks for making the time.
Okay, great. So, this episode explores how HPC has evolved into the operational foundation for AI at scale, and also why data, as opposed to compute, is the primary AI constraint, and how AI is shifting into an operational level. Paul, let me state it this way. We've talked for years about faster compute driving AI. From your vantage point, what's actually limiting AI systems today?
Well, I mean, it's really not a question of a limitation, right? It's what you need to operate AI at scale, right? So clearly the GPUs are improving at great pace, right? I mean, you saw latest announcement from Blackwell to Vera Rubin. I mean, actually, so GPUs are becoming more and more powerful. The networks are becoming faster and faster and getting lower latencies. And so what you really need is you need a data platform, a data intelligence and data storage platform that can really not just keep up, but really enable the GPUs and the network to perform at full scale. And you really need an end-to-end system to be fully tuned, optimized to be able to get the reward and your TCO. So it's really not as much of a limitation that it's really not trivial to get those very large systems to perform at massive scale. And we're seeing it actually with the actual deployment that we're seeing, depending on customers. Some of them are extremely successful because they're basically using the right ingredients, and some of them are really not at efficiency. And so at the end of the day, the GPUs are not performing to what they should do. So it's really a notion of, that's where the HPC, if you want, background comes in. I mean, we're seeing more and more that there's kind of a disconnect between HPC, what we call HPC people, and AI people, because really AI people don't always understand potentially the infrastructure requirements, and that it's really a must and enabling, and whereby the HPC guys have had the experience for many, many, many years to deploy and get those systems at full scale. So right now we're seeing actually a lot of the HPC experts are being hired by the AI natives or by the AI companies to actually help them operate their systems.
We want to really get into that HPC AI theme in just a moment with Shaheen, but if we could talk about the whole notion of data starvation, how that leaves these very expensive GPUs underutilized.
Sure. And obviously, the first level is you're going to invest and use either in the cloud, on-prem, or on the edge, hundreds, thousands, tens of thousands, hundreds of thousands of GPUs. And what's absolutely important is to get them in parallel, fully operating at 99%. And so that's one of the challenges, right? So the first challenge is really being able to have any and all of these GPUs in full speed, real time, access the data intelligence platform, the data storage, and having that data storage being able to respond full speed, real time at very low latency. And that's what DDN does extremely well. And that's really kind of our historic past with HPC. as well as our 10-year, 12-year relationship with NVIDIA of optimizing end-to-end systems. And I think also, quite frankly, NVIDIA deploy a lot of our DDN system all over their data centers and their cloud. So that's the first system, is really the fact of having a parallel access, not like, what you would say like NFS limitations, right? A lot of the other players claim they can do AI system at massive scale, but it's really, they just can't with NFS limitations. And even if they've improved, they just can't. The second issue then becomes data intelligence, access to data, access to massive amount of data, access to metadata, access to orchestration, access to data validation. And this is all basically that has been added in our platform to be able to basically build a end-to-end system alongside NVIDIA.
Very quick question. Do you have any sorts of numbers on GPU underutilization in percentage of it, of total capability?
Sure. It's actually quite interesting. We come in and we have tools. Actually, some of the customers call us, we get into discussions and they might be using either historic enterprise class storage because that's what they had available, or they maybe some of the newcomers. And we come in and really look at what the efficiency at the level of the system is. And you'd be surprised. I mean, we've seen some of the AI natives or the large cloud platform, and we're seeing, 10, 20, 30% efficiency at the level of GPUs. And in very often, these companies don't even know that they're basically running at sub-efficiency, right? So we have tools basically, and we've been working very closely with customers and future customers and prospects to show them really how to optimize, how to build, and what are the best practices to basically deliver with DDN full efficiency on the GPU. It's extremely important for the GPUs to operate fully because that's actually where the core of the cost of the infrastructure comes in.
I love hearing what you're saying, Paul, because as many people know, my personal view is that AI is a subset of HPC, and it's the big killer app that has grown to be huge. I also remember people would say that a supercomputer is a system that turns a CPU-bound problem into an IO-bound problem. And here you are to really address the IO-bound aspect of it.
It's interesting because we're really part of both worlds, right? We've lived the HPC world for 20 plus years. We've lived the AI world, I would say, for 10, 12 years, but really with a massive acceleration over the past 3 years, right? With the event of ChatGPT. And it's kind of funny because we've seen different reactions from the HPC community and from the AI community. So the HPC community was kind of, not laughing, but was kind of smirking about the AI guys coming in, right, at first. And I think they were saying, well, we know all this and we know how to do everything. And the AI guys basically coming in, well, obviously with new models and new training and new technologies. And I think at this point, there's kind of a convergence, right? The HPC community is realizing that actually there is value in AI. They need to evolve their systems into more closer to AI systems, right? Delivering HPC as well. And then the AI guys, in the meantime, are figuring out that, you do need the right data infrastructure guys and the right HPC knowledge to basically get those AI systems to perform at 99 or 100%.
Yeah,
so it's kind of been interesting to see the reactions, right, of the communities. And I think that what's great is that actually at this point, they're converging and people are actually getting on the same line.
Yeah, exactly. I think there's definitely algorithmic and mixed precision convergence, but in terms of infrastructure and skill set and the best practices to build it, I think a lot of those are very, very consistent with what HPC has been doing. And of course, like you said, you have a very long history in HPC. The other thing I wanted to raise was streaming, because I also remember you were in satellite data processing, Hollywood video processing, data processing, low latency, let's not drop a packet, high reliability. All of that now ends up being pretty central to what AI needs to do. Is that true?
Absolutely. So if you look at the history of DDN, right? I mean, 25 years ago, we literally developed a groundbreaking system that would be a parallel access with our own ASIC, our own memory. We delivered a system where no one in the world was really looking at anything like streaming, satellite download, and so forth, right? So that system became instantly a success in HPC. It enabled us to deliver probably 90 out of the 100 largest HPC systems successfully across many years, right, at massive scale. And so what gave us this is basically an experience and the knowledge on how to run at 100% all these massive systems pre-AI, right? So if you look at it, we got, call it luck, call it vision, call it whatever you want, but we really got the experience of, kind of a 15-year head start across any other companies basically delivering AI systems. And this is why DDN nowadays is very valued by our customers, because we come in and we deploy massive system at groundbreaking performance, and we don't blink an eye. I mean, it's basically just installed and delivered, and basically people can go about the business and basically getting results from the GPUs and the network and from the application and the models and so forth very quickly. So clearly this helped us, and it is the value is still today, right? Like you mentioned, streaming, any-to-any, parallel access, low latency. We do not drop a frame. We actually have ability to really maintain the quality of service, online upgrades. I mean, obviously, all the things that you would expect, manageability, planning of workloads, So all this is implemented in the platforms today.
Paul, let's talk about customer issues, the prevalent customer issues you run into. Talk about the transition from pilot AI projects to operational, and what are the key problems, whether it's compute networking or data?
I mean, the problems, obviously, first you have to build the data center, right? Then you need a clear power. You need generation power, you need generators. So the power needs to be clean as well, right? We're seeing a lot of issues potentially with data centers losing power. And when they lose power and the generators don't get in place, basically you have those massive systems basically coming down. And it's very difficult to put them back up, right? So clearly power, cleanness of power, having the right generators is number one. Then, clearly you have GPUs, network, and the data storage portion. On the GPU side, GPU tend to fail, right? GPU will come out, and that's where checkpointing and the fact that DDN enables very fast either synchronous or asynchronous checkpointing helps a lot, because you literally, if you lose a few GPUs, you can really just go back to your latest checkpoint, right? Think about your save on the Microsoft Word or Excel, right? You can really clearly just instantly checkpoint, right? That's one of the massive advantages. I mean, one of the advantages of DDNS is basically that checkpointing that enables you to go right back. You have a 10,000, 100,000 GPU on a simulation that lasts 2-3 weeks or a month for a new model, and you certainly don't want to lose any work when you lose GPU. So that DDN enables extremely well. The other issues become network issues, right? You have network latencies, you have network disappearing, you have ports. And the same way we've been working very closely with NVIDIA to be able to diagnose this very quickly. Every issue points to the data storage or the data intelligence platform. And clearly what we're finding is that about 70-75% of the time, it is a network potential issue. So it's extremely important to have the tools, which DDN has, to troubleshoot, diagnose, and those automatically basically resolve these and get the system back to optimal shape. Then on the data storage, quite frankly, it's about efficiency, it's about reliability, it's about basically predictability. And on those, I think to achieve all this, it's really not trivial at all. A lot of people might be using NFS-based system. They think they're doing well, but the analogy is like using a bicycle instead of a Harley Davidson, right? So you're happy with using a bicycle if you've never done anything different. However, if you go on a motorbike, you'll enjoy that much better and much faster. So again, the same way, I think that when people get on the DDN platform running AI and HPC, they really stay with us for many years. And this is why DDN has been basically a very successful enterprise for the past 25 years. And we anticipate remaining the AI leader in data storage and intelligence.
Let's take a look at the AI landscape, since that's really where the party is. There are reports of tens and tens of chip vendors that are addressing different parts of AI. Many of them build their own systems now. Every one of them really needs to bring the whole compute data, network, memory, the whole thing together. What is your perspective on that? I mean, NVIDIA continues to be the 800-pound gorilla. How do you navigate all of that? How do you make sure you don't get blindsided by something?
I mean, you're going to get blindsided by something anyway, right? Even if you prepare for it. But I mean, that's what makes the life exciting. And that's why we're still working at it, right? That's why my partner and I and our team are still excited every day of the week, right? It's not just by the fact that we're, obviously successful. It's really what we're driving, the passion, and really understanding and enabling the industry that drives us. So when you look at that, I mean, clearly NVIDIA, like you said, 800-pound gorilla, no doubt. But you have other players. You have new players for inferencing. Look at what just NVIDIA did with Grok, right?
Right.
Basically enabling and basically going to integrate the Grok inferencing model because clearly Jensen recognized that they had some value in the space. So I think this is an evolving space. Nobody has the right full answer. And I think as we move forward, because this is still early days in the AI era, you will have newcomers, you will have new chips, you will have new inferencing models, you'll have new algorithm and so forth. And it will basically implement into the market. So it's exciting. It's a very rich ecosystem. We are working with a lot of partners. Our partners is becoming wider and wider. So it's difficult on us and resources, but we are doing it because you don't have a choice, right? The same way you need to be working with the various orchestration platform, the same way you need to be optimizing to models, the same way you be optimizing to different networks. So, I mean, it's part of our heritage, right? The fact that we've been an open system for 20, 25 years. I mean, if you look at it, when we started, it was a heck of a lot more difficult. All the systems were closed, and we had to literally force DDN in on an IBM system or a VAC system, whatever, that were completely closed, and we're able to deliver value there. So today the world is much more open, so we are thriving, and the experience that we've had of delivering systems, no matter what operating system you use, no matter what chips you use, no matter what network you use, is extremely useful as well. We're very flexible in that space.
Right on. Now, there is definitely the whole training to inference part of AI, and the industry seems to be shifting more and more towards inference as it gets used and it becomes part of business processes. But there's also kind of pilot to production. Would you speak to what you're observing in the market as customers transition from training, or maybe they don't even do training, they're into inference, and how they go from pilot to production?
Sure. If you look at the market, right, the market is still driven by probably about 20 to 30 companies, right? The companies that are driving the most of the volumes are the AI natives, the cloud providers, the model makers. Those are still training. The training has been going on and it's still growing. I mean, if you look at it, or even at Jensen's presentation today, right, the models are basically growing 10x in parameters every year. And, people are moving to millions of GPUs, where we thought that 2 years ago, 100,000 GPU would be the goal, right? And at this point, people are talking about 1 million, 2 million, 3 million GPUs. So clearly the training remains and will remain probably for the next 2-3 years. It will require more and more GPUs still, because we're still at the infancy of training. If you look at the data, we're getting into real-time video, we're getting into changes, we're getting into multimodal. So training is still evolving. However, now inferencing is becoming more and more important because those models are efficient, right? And so inferencing is coming in and permeating in all the various industries, fine-tuning, applications. And so inferencing is going to become much wider because it applies, it then permeates into the enterprise. And the enterprise has barely started. Right now, it's in an infancy. People are using Gen AI, they're using ChatGPT, but they haven't really yet some of them have, and you are moving, right? We're seeing pharma, we're seeing some of the medical guys that are moving into production from the pilots, absolutely, but it's still in the infancy. Inferencing, edge, sensors, everything still remains to be created over the next 3, 5, 10 years. It's going to be incredible.
Paul, you all use the term static storage architectures in the face of continuous AI pipelines. How would you describe static versus dynamic storage?
Well, I mean, you have to be dynamic at this point, right? So when you look at dynamic, you really need a data platform that addresses any and all the problems and requirements, right? It's no longer good enough to resolve maybe just metadata, or to resolve just enterprise data, or to resolve mirroring or data movement. You need to be able to do it all. You need to be able to have clearly a cost-efficient way of storing petabytes, tens of petabytes, hundreds of petabytes, or even exabytes, right? We're seeing nowadays exabytes is becoming the new petabyte for companies. So an exabyte is no longer that massive. People are deploying 5, 10, 20 exabytes. So there's an explosion of data. So you need a cost-efficient way, number one, and power efficient, density to be able to deploy those systems. Then the system need to be able to then match and enable the GPUs. So you have a notion of performance, bandwidth, IO to those systems. Then you have a notion of intelligence. You need to be able to retrieve, right? When you want to do a simulation, for example, we are about 500 times faster than anybody else to figure, thanks to our metadata search engines, to figure out which of the objects you want to be able to look for a simulation. Because this is downing. You have billions and billions and tens of billions of files. What are you going to go search about? So you need to be able to do this. Then you have intelligence, KV cache coming in. You have the orchestration. You have the data movement. You potentially also now, with the latest commodity scarcity and pricing issue, you potentially need to look at how do you manage your data across different type of devices. Everybody was rushing to get SSDs or memory. And at this point, the costs are escalating tremendously. So the potentially hybrid infrastructure that makes SSDs and hard drives are becoming super important for those customers, because otherwise they're going to break the budgets.
You mentioned key value cache and some of the other technical challenges that you've addressed. What are some of the more recent challenges? Like you mentioned, simplicity, reliability, serviceability, throughput, scalability, hybrid, NVMe, SSD, like special optimizations for KV cache or for prefill or decode or transformers. And as you pile on and you have a kind of a laundry list of all these things, then some serious optimization emerges because there's a cumulative impact of all of these. What are some of the highlights that they can point that have been challenging in recent time?
So clearly, yeah. So on the training side, I think we've pretty much resolved most of the issues of running really, thousands, tens of thousands, or hundreds of thousands of systems against our system when you do training and those simulation. I think this has been worked, and those are really up and coming and really stable and so forth. When you're talking about inferencing, right, we're still in the early days, and KV cache becomes super important, because think about millions of people doing prompt, right, doing prompt engineering. And the idea of KV cache is that so far, when you do a search, you're literally holding the GPU. That means you have your first search. The system knows very well that you're going to improve your prompt. You're going to go back and make it better or add on some details. So it basically holds right now in the GPU and GPU memory that data. And this is extremely costly. So what you want to do where KV cache comes in is that you're really using DDN as a intermediary storage layer that basically is extremely fast and low latency. So really you have a connection between GPU and us, whereby your prompt gets stored and moved from GPU to DDN, and then at a much lower cost than CPU. So you release the GPUs, but you still have your data and you still have your prompt getting ready to basically being refilled and redecoded after the fact. And so when you do this by millions or tens of millions of requests, KV cache becomes extremely important, because otherwise you won't be able to do it with all the GPUs you have. You're basically keeping them busy for no reason. Does that make sense?
Yes, absolutely. So the other thing that complicates everything that we all do is the emergence of new technologies, new miniaturization. When you look at networking and storage and the emergence of DPUs as a major pivot point there, what does that mean in terms of the system architecture, the hardware architecture that you have to pursue on a roadmap? What does that do to the roadmap?
So actually in our case, right, DDN is really software, right? Historically, we've delivered complete systems because customers like a one throat to choke, right? You basically have a one point of support and you have someone responsible for the quality and the efficiency of the full system and the performance of the full system. But really, 97% of what we do in IP and R&D is software. And so our software, actually, our latest software called Infinia, is really a groundbreaking platform that is built for the AI times. So you can load, you can actually load on your PC or your Mac, you can load on a DPU. So you can literally kind of run that software, call it inferencing software, that basically can run on a DPU, on a sensor, and at that point validate data and move it to your core to be able to basically extract the value of what data you really need. So think about DDN of a really kind of a evolution from complete system, which we will continue delivering, but really to a software play that can load on DPUs, on memory close to a GPU across, and so no matter what the application might be. And so think about robotics, humanoid. We think that there's a great future of a DDN with NVIDIA and other robotics company to basically deliver software value to manage and be able to basically drive those humanoids.
Related to that really is, what is a system anymore? Because if it becomes more and more modularized and there's software glue that brings it all together, doesn't that impact the definition of what a system is?
Well, I mean, the system is whatever you define it, right? I mean, historically, you think of a server, you think of network, you think of all that, and that's going to change, right? You're going to have basically, it's going to be all about some type of a GPU or intelligent or DPU unit, but at that point, the software can run very close to that GPU and DPU unit. That's going to be super important, especially on the edge, right? And so the software and the intelligence software is going to become more and more crucial, because not only do you need access to data, you need to be able to ingest it at the right performance, you need to be able to validate it, you need to be able to have some intelligence there to keep whatever data is going to make sense or not.
Paul, explain for our listeners the issue around sovereign AI and the notion that sovereign AI is emerging as the default operating assumption.
Right now, there's a battle for intelligence. You see it, you hear it from the president, you hear it of the battle between the US and China and other countries. And really, it's a notion of creating intelligence, right? So the AI factories, the sovereign AI factories, it's a notion that each of those countries is going to need to build their own intelligence and sovereign AI factories for their services, for their R&D, for their universities, for their people, for their IP, for the delivering easier system to their citizens, right? Like getting a real-time passport, or just a passport on your phone, or getting just walking through the airports at this point and not having to speak or see anyone, and then just being cleared directly. I mean, there's so many support and services that can be improved. But sovereign AI becomes something where you control your destiny, you control your IP, your data, your intelligence, and at the end of the day, it's all about data and your creation. So it's going to be super important for each and every country, which we are seeing, to build up their own AI value. And it doesn't mean really. And so people say, well, yeah, but you're still buying NVIDIA, which is an American company. But that's irrelevant. I mean, it's really because those are the tools. What you're creating on top of it, then you own that, right? So it's super important that, not every country is going to have the technology. They need to source the technology, install it in country, and control basically what's coming in and keep it within country.
So I wanted to turn the conversation to the future. We've seen really the emergence of AI, not just as a user of storage, but as an enabler of future storage. We've talked about semantic storage, computational storage. What does that do to the future of the data management aspect of AI, whether it's hardware or software?
It's what we said, that to be efficient in the AI over time, you're going to need to be able to have, call it closely to an operating system for data. And this is what DDN has been building, which is really a notion of addressing on-prem, cloud, edge, as well as different type of computational, either in-chip computation or close to networks. I think at this point, what you will need is kind of ideally a solution that encompasses all the various use cases in a very simple way, and that can scale easily as well. So this is software-based that loads, and basically it's very flexible depending on the either chipsets or network set or DPU set or whatever is going to come up. And this is what we've been working on and deploying.
So, Paul, talking at scale in AI factories, the part of the market that you're really addressing typically, where do things break down first? Compute network or data? Where do you see the most common problems that your customers are up against?
The problems are going to come from pretty much every component of the system, right? From power, from GPUs, from network, or from data storage. And what's super important is to build redundancies across those, right? So when they hit, that either they do not impact the full production, and then second, that you basically get back to full production as fast as possible. So there's going to be issues, right? You're talking about, we spoke about power potential issues, generators, having to reboot systems. You want to avoid all this. GPUs will fail, but then we have models that get, like checkpointing and ways around this so that you do not lose your simulation that you've been working on for weeks or months. And then network is probably where the core of the issues come from, right? There's inherent instability from time to time. When you push the network, you get some issues. And so that points to the storage, but then the storage. So it's really crucial for whoever to have elements on the data storage and to have elements on the data storage people to be able to alleviate when the issues are storage based, data storage or data intelligence based, or when they're network based, right? And we look at most of the system, most of the issues come from network, but you still need to resolve them. And that relies upon then basically the data storage guys to say, yeah, this is the issue, this is the trace, this is where it's at, and this is how to resolve it. So we've been working very closely. We now have automated tools to be able to do this because at the end of the day, what AI systems, the big difference between AI system and HPC is that AI system cannot go down, right? They need to operate 100% of the time, no matter what. And this is basically things that we've had to work on extremely in details over the past 3-5 years, because when you talked about the old times of HPC, these people would understand why a system would potentially go down or what the issues were. In the age of AI, nobody cares. People want online system 100% of the time. If you have issues with SSDs or servers or controllers or whatever, you have to resolve it in the background while the system is performing. So this is obviously a pretty big challenge, and this is the one that we're tackling pretty efficiently.
That's excellent. I've heard you use the word operationalization of AI, and that sounds like what causes these requirements to appear in a big way and AI becoming more of a mission critical thing rather than an app that you're running in the background.
No, absolutely. Think about it. I mean, you basically, it's quality of service. It's the old way of your phone. You know, like when your call would disconnect, well, at this point, you need the AI system to perform 100% of the time. It's becoming as crucial as a banking system or more crucial. When the access to AI, especially when it's going to permeate to digital transformation or industry or omniverse or your plant or your medical systems and everything, it needs to be 100% operational. And so that's really what we've been aiming at. If you look at the efforts this year, we are gearing towards that 100% uptime. That's really what we hear from customers, right? They want uptime full on. They don't want to sustain any type of a downtime of upgrade or whatever. It needs to be uptime full on.
Excellent. Doug, what have we not asked? Or Paul, what have we not asked?
No, I mean, again, it's an exciting time, right? I think that it is challenging. I think people are super stressed because there's so much happening. Think about an industry which is developing, 20, 50, 100, or 1,000 different ways. And you have to be basically up on all these issues, all these challenges, all these opportunities. And I think it is an interesting time because everybody's working probably 2 times or 4 times more than they were before and still not believing they're achieving a full result because there's so much to be done, right? So I think there's kind of a new wave of kind of feeling of that I've been talking to people, right? And they feel that the more they work, they're still not fully satisfied because they cannot complete all the tasks they have. And I think you need to be able to kind of evolve and adapt and do the max you can. But at the end of the day, you're not going to be able to do everything. So you need to focus on what's super important and what you're going to be able to do and add the most value. But The AR era is going to change profoundly the world. I mean, the world, the way we work, the way people interact, everything. And you have to. I think at this point you have to embrace and basically learn the tools the same way. When people ask me, "Well, is AI going to replace my job?" I say, "No. If you basically embrace AI and actually enhance what you're doing and provide more efficiency, you basically have job security." So it's a notion of a really kind of a pretty, I think, exciting time, but at the same time challenging. And so people are going to have to evolve and accept that AI is here to stay.
Paul, I had one just as an aside. I was talking with Alex at SC in November, talking about this whole notion that you all have been in HPC storage for all these decades. And then as AI really emerged, it was apparent that this would be the next wave, even if it is, as Shaheen likes to say, AI is an HPC workload, but that you were well positioned to take full advantage or to leverage or to ride this next wave. And he said the key moment that he was convinced that you all were in the right spot was when ChatGPT came out 3 years ago in November. But I'm curious if that news, that explosion of LLMs and generative AI, if that was a difficult transition for DDN.
Yeah, not at all. I mean, if you look at it, I mean, I will tell you the one thing we saw pretty early is the alignment with NVIDIA and Jensen, right? We did this about 10, 12 years ago. And I think that was kind of the paradigm shift, right? We basically aligned our engineering, we aligned our understanding, our vision into understanding what NVIDIA was doing and really partnering with them. NVIDIA starting using DDN systems across all of their internal systems and cloud, right? And so that created a lot of engineering value, a lot of learning. It was not about marketing or selling. It was really about moving the industry and delivering end-to-end system that would deliver AI. So clearly we had been working for probably 7-8 years when ChatGPT came up, right? So we had built a lot of large systems alongside with NVIDIA or NVIDIA customers. We were the first one delivering, 100, 200 superpods with NVIDIA, with the only data storage platform there. And so really we were ready for the ChatGPT moment. What ChatGPT did for us is really not as much challenge us, but just basically delivered many, many, many more opportunities across the world, right? And delivered more business outcomes. But I mean, no, we're ready. I mean, DDN has been ready for the past, 10, we learned for the first 15 years how to deliver very large systems at full performance, at full efficiency, at the best price points. And basically with AI, we're now clearly optimizing for AI, but we were built for that. And so we know about it.
That'd be my take too, Doug, that the market came to DDN rather than the other way around. It's sort of like suddenly everybody wants what we've been doing for years, and isn't that great?
Only more so, right?
Yeah.
Yeah.
No, that's exactly right. I mean, what we saw is that instead of having basically a population of potential 500 customers in the world, right, when we were in HPC, with all the various large data centers, we now have one much larger potential single customers, and obviously many more of them. So it's like you have to review that a very large HPC system or DOE. We're spending basically 500 million or 600 million on a very large system, right? 3, 4, 5 years ago. And nowadays, people are spending 1 billion, 2 billion, 5 billion, 10 billion, 50 billion on system, like it's, no problem.
Right on.
So there's an explosion out there, which is quite interesting.
So, Paul, in the context of what do you see looking forward, you mentioned that a little bit, but how do you see the strategic decisions that you need to make? Is DPU a threat or a leverage point? Does it accelerate you becoming more of a software company and therefore no worries, we're just going to layer on top of what they do? Or is that a threat? Have you considered doing your own systems?
Yeah, no, absolutely. No, I think it's enabling because you're going to need the edge to core to cloud on-prem. You're going to need all the system to basically perform efficiently and in unison. And for that, you need potentially fully optimized and built specialized hardware and software systems, right, for the core training system. And then when you come to DPU or sensors or humanoids and so forth, you only need software and be close to the unit that of intelligence in this device.
Okay.
So really, it's not a threat; it's a convergence. We align completely with NVIDIA. We align with the other partners as well. And this is really what makes it very exciting for us: is that we have the right technologies to be able to deliver the solutions, no matter what you're trying to
Right.
gain. Right.
Right.
So you could be at small scale, you could be at medium scale, you could be at massive scale, you could be training or just inferencing. I mean, the data and the IO profiles from training or inference are very different, right? The challenges is extremely different. And interestingly enough, right, we're finding that in some of the early robotics testing that we've done, is that we're finding that actually some of the performance, the bandwidth, all the metrics remain, that to enable value and TCO on your investment, you do need the data intelligence platform to deliver performance. And that's where DDN is king, the performance. So when people realize that they do need the performance, we're the only ones delivering that extreme performance at any scale. And that makes a huge difference at the level of the investment.
Yeah, it may just be me, but I think what you do at the edge, I'm less familiar with. I obviously know that you've been in the data center and, et cetera. But I think that edge part is really exciting.
This is really new, right? I mean, if you're looking, this is really evolving, right? This is going to happen over the next 2-3 years. Mm-hmm. It is loading on DPU. You saw the announcements with Bluefield 3, now Bluefield 4 with NVIDIA. And so we're able to really not just use them as cars or extension, we're actually able to run our software on a DPU, right? So you do not need CPU or a GPU. All you need is a GPU and our software to run basically inferencing, software validation, and so forth. So this is something that we are working on, and that is in part. But I mean, as the market evolves, we are ready for it.
Yeah. No, that's also a good answer. Thank you.
Okay, Paul. Well, wonderful discussion. We've been with Paul Bloch, president of DDN, and thanks so much for your time.
We could go forever, and I really appreciate your time, Paul. Thank you.
Thank you, Doug and Shane. Really appreciate your time, and that was a great discussion. Appreciate it. Thank you.
Very good.
Take care.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.